Hello, everyone. This is Chapter 16, Decision Analysis. We are Group 6. I'm Jeff Stoner.
I'm Alec Livermore.
I'm Matthew McMaster.
I'm Iryna Khalymon.
I'm Taiye Olugbade.
First off, we have decision strategies without outcome probabilities. We have aggressive strategy, which is considered optimistic. It accepts the option that holds the promise of minimizing potential loss. And you often ask the question, what's the best that could result from each decision? Second, you have the conservative strategy, which is considered pessimistic. It selects the decision that represents the best of the worst. Pessimistic attitude, you often ask, what's the worst thing that might result from my decision? You also have opportunity loss strategy, which is a third approach that underlies decision choices for many individuals to consider the opportunity loss associated with the decision. The decision strategies for maximize objective. For the aggressive strategy, the best payoff would be the largest value among all outcomes. For the conservative strategy, the worst payoff would be the smallest value among all outcomes. And finally, for the opportunity loss strategy, with a maximum objective, the decision with the largest value for a particular event has an opportunity loss of 0.
So next we got decision strategies with outcome possibilities. So you have average payout strategy, expected value strategy, and evaluating risk. And then on the side there, I added a little picture to kind of explain the outcome probabilities. So going off this is part 2 of my last slide. The average payoff of a strategy is the sum of the payoffs for each possible outcome multiplied by the possibility of each outcome, calculated on average for the entire population. Next, you would use this second method when probabilities are available, and you can use that expected value strategy to identify the best decision alternative. And then coming in at number 3, we got when evaluating risk, it can be used to provide probabilities for the payoffs associated with a decision alternative.
So the next useful approach to structuring a decision problem involving uncertainty by using a graphical model called a decision trees. Many decision problems have multiple sequences of decisions and events. That's why decision trees are invaluable in helping managers understand the implication of uncertainty. Decision trees consist of a set of nodes and branches. There are 2 types of nodes, decision and event node. The decision node is expressed by a square, and it represents an event of selected decision from among several alternatives. Event node is depicted by a circle, and it represents an outcome over which the decision maker has no control. Branches are associated with decisions and events. It is used triangle to represent the terminal point of a decision path. To find the best decision strategy by using a decision tree, we need to roll back the tree by computing expected values at event nodes and selecting the optimal value of alternative decision at decision nodes. Decision tree and risk. The decision tree approach is an example of expected value decision making. However, this approach does not explicitly consider risk, such as magnitude of payoff and their chances of occurrence. We can use the risk profile that show the possible payoff values that can occur on and their probabilities. The probabilities are computed by multiplying the probabilities on the event branches along the path to the terminal outcome. We can also use Excel data tables to investigate the sensitivity of the optimal decision to changes in probabilities or payoff values. So now I would like to share the video example of how to construct decision tree in Excel.
I'm going to show how to use this free BY tree plan add-in to construct a decision tree in Excel. Go online and search for YBN tree plan. Select this one on GitHub. Click on code. download zip. Go to the downloaded zip file and extract it. Now close Excel if you have it running and relaunch it. On a Mac, you will go to Tools, Excel, Add-ins. But here in Windows, go to File, Options, Add-ins. Then click Go here. Click Browse and go to the extracted tree plan master folder. Double-click to select the BY tree plan file and click OK. You should now see a tree plan tab here. I'm going to be constructing a decision tree for this payoff table. Click on the tree plan tab. Click New, and you can start your decision tree with 2, 3, 4, or 5 branches. I have 2 alternatives, so I'm going to start with 2. Then I'm going to click in the cell at the end of the branch here to add a chance node. Tree plan, then change to event with 2 branches. I'm going to create a decision node at the end of the second branch here. Tree plan, change to decision with 2 branches. Now I'm going to label these states of nature. The probability is 0.6 for S1 and 0.4 for S2. I'm going to add the payoffs quickly. You see here that it chose the better payoff since this is a decision node. And here, it calculates the expected value. And it chose the better value of these 2. Now, suppose D2 has the same structure as D1 as seen here. I can copy this part of D1 into D2 by clicking in the cell containing this node. Do not click on the node itself. I'm going to click below the node and use the up arrow key to select the cell beneath the node. Tree plan, copy subtree. Now I'm going to paste that subtree here. So tree plan, and I'm going to paste subtree. And that subtree is pasted down here. And if I add these payoffs here again, it automatically does the calculation and chooses 688 over 680 here. Now let's suppose my decision table is very basic like this one. So I need to get rid of these decision nodes. I'll click tree plan, then change to terminal for the first alternative. And do the same for the second alternative. Again, on adding the payoffs, we see the expected value is calculated and the better one selected here. Finally, if I want 3 branches for this node, I'll select the cell under it, tree plan, add branch. And that's BY tree plan. Thanks for watching. I'm going to show how to use
The value of information. The value of information represents the improvement in the expected return that can be achieved if the decision maker is able to acquire before making a decision. Additional information about the future event that would take place. Perfect information tells us about certainty, what outcome will occur. The expected value of perfect information. Expected value with perfect information assumed at no cost minus the expected value without any information. Again, it represents the most you should be willing to pay for perfect information. The expected opportunity loss. The average additional amount the decision maker will have achieved by making the right decision instead of the wrong one. Decision with sample information. Sample information, result of conducting some type of experiment such as a market research study or interviewing an expert, always imperfect. The expected value of sample information. Expected value of sample information is sum at no cost minus the expected value without sample information. It represents the most you would be willing to pay for the sample information. Bayes' rule. Extend the concept of conditional probability to reverse historical probabilities based on sample information. And that's an example.
Okay, so this slide deals with the utility function and the exponential utility function. The utility theory is an approach for assessing risk attitudes quantitatively. The important component of the utility function is the certainty equivalent, which is the process that represents the amount that a decision maker feels is equivalent to an uncertain gamble. Normally, companies try to avoid gambling because of the uncertainty of it. Most times, the negatives of taking a risk outweigh the positives. This is measured by the risk premium. The risk premium is the amount an individual is willing to forego to avoid a risk. This is when companies will take a risk-adverse approach to make sure they don't take a loss. The utility function is great, but it struggles when the situation at hand involves a large number of payoffs and when the decision maker is risk-adverse. This is when we would use the exponential utility function, and the formula is right there next to the formula tab. So the case study question for this chapter involves case performance and lawn equipment. Case's lawn equipment sector has focused more on the needs of a summer months, like your springs, your summer and fall months of the year. They're looking to sell snow blowers so that they can increase sales numbers during the winter months. This is risky though because of the amount of competition in the market, and that Case has never dove into this market before. Case is looking to use some of the equations that we learned in the chapter to evaluate the risk of jumping into this market and if it's worth taking, if it's worth getting into the market or not. This is a great real life example of how the material in the chapter is utilized by companies to become more efficient decision makers. I would definitely recommend trying this problem on your own.
And then as for our discussion questions, we got number 1, which is give an example of a time where you used any of the strategies mentioned in today's presentation.
And our second discussion question is explain when you should use an exponential utility function instead of a utility function. Thank you all for watching.